Now let us take a speed time graph. So as I told you, time will always be taken on x-axis and speed on y-axis. We can plot the graph exactly in the same way. At different time, different values of speed according to the scale that we have chosen. We can write the speeds here, time here, find out the points and then join. I will discuss the nature of few particular graphs. Suppose for a body we have this speed time graph, and here the value I can take randomly, let me say 20 km per hour, and 1, 2, 3, 4, let the time be in hours and the speed in kilometer per hour. At 1 hour the speed is 20, 2, 20, 3, again 20, 4, again 20. What does it mean? That the speed of the body is not changing. It is moving with constant speed. Speed upon time is acceleration. So just as using distance time graph we can find out the speed, displacement time graph we can find out the velocity by finding the slope. From speed time graph we can find out the acceleration. Slope means this quantity divided by this quantity, the quantity on y-axis divided by the quantity on time axis. So it will be v2 minus v1 upon t2 minus t1. For this particular graph this is 0 because v2 and v1 are same. So 0 acceleration. Okay. If I have this, and so on. Let this be the speed 4, 8, 12, 16, 1, 2, 3, 4. Now the slope is coming constant. So what will be the acceleration for this? Again, I can take any 2 points. Suppose I take these 2 points, v2 minus v1 upon t2 minus t1. So it is 4 and units are kilometer per hour square. So this will be the acceleration. So using a speed time graph we can find out the acceleration of the body. A graph parallel to time, constant speed, 0 acceleration. A graph like this, constant slope, it means acceleration is constant. So from a speed time graph we can find out acceleration by finding the slope. We can find out one more quantity from this graph. Again, let me take the same example, 20. We may have 5, 10, 15, 20. This is speed and we can take here time in hours. If I ask you calculate the distance in say 4 hours, how much distance? See, I told you this quantity divided by this quantity, this gives us the slope, and we can find out acceleration by finding the slope of a speed time graph. From distance time, distance upon time is this speed. displacement upon time, that is velocity. Speed upon time or velocity upon time, this will be acceleration. From velocity time graph or distance time, speed time graph, we can find out one more quantity, that is distance or displacement. So speed time graph can give us distance, velocity time graph can give us displacement. Now see how will we calculate. It has constant speed. So distance will be speed into time, 80 kilometers. How can we find that? We can find out this area. This is the speed and this is the time. So 20 into 4. So it gives us 80. So actually area, we call it area under the graph. So area under the speed time graph will give us the distance. But keep in mind, area doesn't mean that it is meter square or kilometer square here. Because here, when we are calculating the area, this is kilometer per hour multiplied by hours. So it is kilometer. So units are not same. We are just calculating this area of this particular rectangle formed. But on this side we have speed, on this side we have time. So the area is not kilometer square or meter square or centimeter square. It is kilometer per hour into hours. So which gives us kilometer distance covered. So what have we done so far? Speed time graph will give us the value of acceleration from slope, and area under the graph will give us distance. Now let us see how it differs from velocity time graph. We all know what's the difference between velocity and velocity is a quantity for which we need direction. It may be positive, it may be negative. So if a body is moving in this direction, if we take its velocity positive, the moment it turns its direction and it starts moving, the velocity is negative. One more difference between displacement sign and velocity sign. Displacement is always taken with respect to the origin. If I take this as the origin, if a body is moving like this, it is positive displacement. Even now it is positive. Even now it is positive, it is 0. Now it is negative. So it is always in reference to the origin. To the right, positive, to the left, negative. So to the right, whether it is moving away or coming closer, it doesn't matter actually. We have to take the distance from here. So it is always positive, so long as the body is on this side. For velocity, it is not so. For velocity, we have to see the direction in which the body is moving. So if the body is moving like this, its velocity is say positive. The moment it starts moving in this direction, velocity becomes negative. If we throw a body in upward direction and we are taking its velocity as positive, so when it is coming down, we will take it negative. So velocity can be positive as well as negative, but its speed is always positive. So a graph may be like this. It means from this time to this time, say t1, the body is moving in one direction, positive. From t1 to t2, it is moving in opposite direction. So from velocity time graph, you can tell the direction in which the body is moving. And from slope, we will get acceleration exactly in the same way as we did for speed. Any 2 points and then v2 minus v1 upon t2 minus t1. This is how we will calculate the acceleration. Area under the curve, that will give us displacement here. This area will give us the distance covered when the body is moving in one direction. This is the distance covered when it is moving in this direction. 0 to T1, I got this distance. T1 to T2, I got this distance. So if I do this plus this is the distance. If I do this minus this is the displacement. So this area, let me say A1, A2. Total distance covered by the body. This plus this. And displacement A1 minus A2, this minus this. Because this represents that the body is moving in opposite direction, so this distance is to be subtracted to calculate the displacement. Right? Let me take one example. Time in seconds, and here velocity in meter per second. And I ask you calculate acceleration for the intervals OA, AB, BC, CD, DE. Then total distance, and then total displacement. Then how will we go? Acceleration is always calculated from the slope. So acceleration in interval O to A, V2 minus V1 upon T2 minus T1, 0.5 meter per second square. Right? It's 10 minus 0, 20 minus 0, slope gives me the acceleration. Acceleration from A to B, 0, the velocity is not changing. Acceleration from B to C, it is, velocity is decreasing, 0, minus 10, 40 minus 30, minus 10 upon 10, minus 1 meter per second square. C to D, at D minus 5, at C 0, 50 minus 40. Then D to E, E 0, D minus 5 upon 60 minus 50, 5 upon 10, 0.5 meter per second square. right? O to A 0.5 because 10 minus 0 then 20 minus 0. A to B, it is at rest. Sorry, velocity is not changing, it's moving with constant velocity. So acceleration is 0. Then B to C 10, 0 minus 10 and time is 10. Now here 40 to 50 in 10 seconds the change is from 0 to minus 5. So minus 5 minus 0 upon 50 minus 40 to 0.5 and same way here. Now let us calculate the distance and displacement. Distance is area, total area. This plus this. So I am taking this as trapezium and this as triangle. What is the area of this? Half sum of parallel sides 40. And how much is this side? 10. This side is 40. This side is 10. 30 minus 20. So half sum of parallel sides. Distance between the parallel sides. How much this is? 10. So it is this plus this triangle also. Half base into height 5. This is 50. 50 into 5. 250 plus 50. So it is 300 meters. This is the total distance. This plus this. What about the displacement? This minus this because it is in opposite direction. This gives us the distance covered from 0 to 40 seconds. And from 40 to 60 the velocity is negative. It means it is returning. So for calculating displacement, this minus this. This is the area and this one is this area. So this minus this will give me the displacement. So this will be, I can use these results only. This area is 250 and this is 50. So it is 200 meters. Again, in a nutshell, we can plot a graph between two quantities, time always to be taken on x-axis. We have done distance time graph, displacement time graph, speed time graph and velocity time graph. Displacement time graph and distance time graph, they are used to find out velocity and speed respectively. d2 minus d1 upon t2 minus t1 from the slope. Speed time graph, we can find out the slope to get acceleration and area to get the distance. Velocity time graph, slope will give us the acceleration and the area will give us the displacement. So that's all from this topic, and in next class I will take the equations of motion. We will use velocity time graph to derive those equations.